Hey, hi everyone. Hey, thank you so much for that intro. It's
Yeah.
good to be here at SysConf. I think this is my first time speaking at SysConf, but I'm someone that's been close to the community for a while. Um, I'm someone that's been aware of everything that SysConf is trying to build, so it's lovely to be able to be here and speak at SysConf. I'm actually supposed to be doing this talk alongside my very good friend Ridwan, but just having a little bit of technical difficulties and I'm unable to reach him at the moment. What I'm going to be speaking about is something that I'm actually quite passionate about. So Ridwan and I spend a lot of time building software applications in Elixir. Now, for those of us who might not be familiar, Elixir belongs to a family of programming languages. Um, that are functional programming languages and they run on the Beam. As we go through my talk today, I would, tell you a lot more about what the Beam is, the Beyond Abstract Machine. And essentially, you can think of it as some sort of GVM that is used to run a family of functional programming languages. Erlang was the first language. Elixir has come, and we are even having Gleam, which is a strong typing implementation of these languages, right? Um, my talk today is going to be a lot about talking about Whisper, which is a multi-agent system, and also a bit about talking about Elixir. My goal is to evangelize and see if we can get more people, especially more people from Nigeria, from Africa, to get into this family of languages, to get into the habit of writing functional programming languages, right? But before we get into all of that, let me tell you a bit about myself. I'm currently vice president at Bank of America. I'm based out of Dublin, Ireland. Majority of the time, you would catch me writing Elixir, Python, JavaScript. I also spend some time trying to write low-level languages like Zig and C. And then a bit about my friend. My friend is Reed Warren. He is currently vice president of engineering and product at GCWay. GCWay is a startup, a stablecoin startup based out of the US with lots of clientele and customers in Nigeria and Africa. Ridwan spends a lot of time writing Elixir, Ruby, and Zig. And in fact, Ridwan was the one who evangelized me to start writing Elixir about 4 or 5 years ago. Ridwan lives out of London in the United Kingdom. So for those that are in that location, you might have met him or you might meet him, right? Um, okay, agents, right? So I think the last two, 1.5 years have been very buzzworthy, right? From OpenAI's big moment in 2023. Since then, I don't think we haven't had peace, so to speak. And I think agents was probably the last set of the buzzwords. And the question is like, what really are agents? And if you ask anyone who writes Elixir or anyone who writes a functional program language, they'll tell you, to them, they know what an agent is supposed to be, right? Because we've always had this concept of an agent within functional programming paradigms. And within functional programming paradigms, an agent is basically an encapsulation of state. So one of the key facts that go with functional programming languages is the immutability of data, right? While you also have this in other paradigms within functional programming languages, it tends to be a non-negotiable, right? And so for you to be able to access state, you would typically use a concept like an agent, which will encapsulate this state, provide an API that other processes can reach out to and basically get that state from it, right? As compared to having state stored or an object in the object-oriented programming paradigm, right? So for people writing Elixir, agents was like, okay, yeah, you all are now talking about agents, but we've always had agents. But that's not the agents we're here to discuss today, right? We're here to discuss AI agents or agents within the concepts of AI supercharged or turbocharged workflows. And what are those going to be, right? Um, you know, you might have heard about agentic workflows, LLMs, tool calls, MCP servers, multi-agents, what really are all of those going to mean, right? In terms of like practical usages, practical terms, right? I think MCP servers were a paradigm introduced by Anthropic, and it's basically like a methodology, a modality for you to provision or make available a series of an interface, right, that you can use to access an AI agent back workflow, so to speak, right? And then tool calls are quite analogous to that. Next to that, and the concept of tool calls is, for example, if you had, let's say, like a video conferencing app that had some sort of LLM or AI based interface, tool calls would basically be some form of API, right? So I don't know, you might have started noticing that there is a lot of similarities between some of these new paradigms that we are getting within this new LLM-based AI-driven world, and some of the fundamentals with with software, with computer science, right? And it's all APIs, it's all interfaces, it's all establishing protocols for different components of systems to speak to each other, right? And it goes, I was just in Ayo's earlier talk, right? It goes to basically validating that, if your fundamentals are strong, you'll be able to adapt to wherever the industry, whatever new technology is coming into play, right? But let's move on with it, right? When we talk about agents within AI workflows, right? What are what does that really mean, right? So, for example, if you're a power user of Cursor or you're a power user of GitHub Copilot, right? I think Copilot has three modes: Ask, Edit, and Agent. And if you ask yourself, what does agent really mean when you're using GitHub Copilot, right? Or when somebody says that, oh, within our Figma app, we now have AI agents. Are those agents fully autonomous? Do those agents use various tools? Do those agents use predefined workflows? And the answer to that is, all of the above. Ideally, these agents, right, when you're using GitHub agent workflow, ideally that workflow should be fully autonomous. I'm saying ideally because I'm going to introduce something later on that, in my opinion, I think invalidates the idea of it being fully autonomous, right? Do they use various workflow tools? Yes, they do. I think that's one of the strengths of agents today. The fact that they can have an idea of all the tools that are available to them, and using an LLM system, they can basically determine what needs to be done, access what tool is available, and execute those tools. Right. I think that is one of the strongest selling points of agents today. And if you're thinking about it, right, that is kind of like what you would have done in traditional software engineering, right? It's just that the decision making process is now sort of turbocharged by an LLM, right? Now, predefined workflows. This is the not so glamorous part, but the part that is essential to success, right? You can't have an agent running in the world. You need to have a mechanism for determining, when should an agent run, when should an agent complete, what sort of systems should the agent interact with, right? So having having a workflow, that specifies the constraints of the environment or the system that the agent is working in is crucial to building successful agents, right? And what I have here is a lot of what I've said, right? AI agents today, I don't think you can't say you have an agent within today's workflow, right? You can't say you have an agent if it's not backed by an LLM. Today, that's the idea of what an AI agent is. An LLM is somewhere in that loop. They are turbocharged by getting access to memory, getting access to retrieval tools. As we begin to see a lot of traditional systems beginning to support AIs, beginning to provide MCP servers, a lot of libraries beginning to provide tool calls. The ecosystem around which these agents can really thrive continues to expand, and they typically will interact on an MCP server, right? So this would be what your AI agents have today. If we spoke a bit about what agentic workflows are, right? When somebody comes and says that, oh, we are using an agentic workflow, what does that mean? A lot of times it's a fancy market speak, but to us engineers who need to be on the ground and have the detail, right? An agentic workflow would basically be where you've identified a sort of a complex task, right? So, for example, I think there was a recent demo by OpenAI, where they showed that you could use Atlas to book an holiday, right? What that would look like would be that the OpenAI team would have defined a possible workflow for what should be done when you're trying to book a holiday, right? You probably have interactions with Booking.com, Airbnb, with your favorite airliner, and using an LLM, you would basically orchestrate different stages of interacting with all of these required interfaces, right, to execute that action. That's what an agentic workflow would mean today. Now, traditionally, what are some of the ways that you could execute an agentic workflow? Multi-agent systems have been in place for a long time, since like the 90s. They were especially popular. If you go back and do some research, you might see some earlier papers, sometimes in the 60s and the 70s, right? But I think in the 90s, there was a little bit of computerization regarding the approach to be able to set up multi-agent workflows. Now, this were not AI backed. This was just, oh, if you have to sequence a set of operations and you're calling them agents, how could you do that? And the two big buckets that emerged are sequential and parallel, just like you have in almost everything today, right? Do you execute units of work in sequence, or do you parallelize them? And under the sequential model, there are two big tranches. There's what's called the classifier router and what's called the sequencer orchestrator. Whisperer is actually built using the sequencer orchestrator model, but I will say a bit about the classifier router strategies as well as the parallel strategies, right? Now, what happens within a classifier router strategy? A classifier router strategy, in many ways, is very easy to maintain and to visualize and to conceptualize. And what you do in the classifier router strategy is you basically take in an input which is probably, which can be, condensed into an objective, right? What we're trying to achieve with this workflow. And what happens is your classifier, who is aware of, the different agents that exist, would then say, okay, what you're trying to do today is you're trying to issue a refund, right? Let's say you wanted to cancel your booking at Airbnb.com. The input receives that action, the classifier classifies which agent should execute it, and then it passes it on to that agent, right? So in many ways, it's very scalable, and it's, how will I put it? It's probably the strategy that will give you the least worry in terms of something breaking along the lines, just because it's quite straightforward, right? The sequencer orchestrator workflow, which is what we've gone with Whisperer, is a lot more verbose. And what I mean by that is, with the sequencer orchestrator model, what you typically have is you would have an LLM-based orchestrator, which is the brain box of this entire workflow. And what happens is, when the input is received, the orchestrator is aware of all the different agents that exist within that system, right? And the orchestrator determines, using an LLM today, that, to be able to issue a refund request, right, I first have to basically confirm that their request has been cancelled. Maybe there's a cancellation agent. I have to maybe suggest new possible booking options to them. I have to confirm that they are not, interested in continuing this booking. And then when all fails, I have to, you know, uh, within our own system, maybe, roll back that booking and then maybe issue to some sort of payment system to, refund that money. Whatever is the business logic, right, that exists, that's been encapsulated within different agents. What the orchestrator does is it basically identifies that for us to be able to complete the full execution of this particular input, we need agent A, agent B, agent C. And it then goes through the work of taking in that input, deploying it to agent A, expecting an output from agent A, taking that, giving it to agent B, expecting an output from agent B, taking that, giving it to agent C, expecting an output, and returning it back to the end user, right? Now, the orchestrator can also determine that it's not necessary for it to take inputs, for it to cascade those inputs and outputs. Maybe it only needs to cascade A and B and trigger C separately. The idea is that this orchestrator is the all-knowing scheduler, so to speak, right? And while that can have very great impact in terms of like your business use case, right? In terms of being able to orchestrate very complex strategies, you introduce a bottleneck of the orchestrator, right? So the orchestrator has to be involved in, executing all of these workflows, and so that can represent, scaling concerns, that can represent point of failure concerns for you. But in terms of like being able to achieve complex business scenarios, the sequential orchestrator workflow tends to be ideal for those scenarios, right? And of course, you have the parallel workflow. Parallel workflow is great in terms of performance, just like we would have with some of our traditional software techniques. Great in terms of performance, but the issue with parallelization is that you would not necessarily be able to build complex scenarios or complex use cases if you're using purely a parallel strategy, right? Because you can't execute something like, confirm that they are not interested in any optional bookings, as well as refund their payments. You can execute those two business scenarios at the same time, right? So a parallel workflow would not work for you in that respect, right? Overall, I think the success in building a multi-agent system is not necessarily about taking an off-the-shelf solution. I think it's a lot about identifying the domain you're playing in, right? So, for example, are you trying to build agents for a chatbot system? If you're trying to build agents for a chatbot system, you can probably get away with something like the classifier router strategy. If you're trying to build in a complex domain, which is what we're trying to do, right? We're trying to build MonitorLizard, which was an observability AI-driven tool. And the idea, the core of the platform of MonitorLizard was when your observability stack could basically highlight issues that you have with running your suite of applications, and based on the traces, the spans, the errors that we receive, we could basically take that, analyze your code base, analyze the running application, and issue suggestions as to fixes, right? So because there was some sort of complexity involved in that domain and handoffs between different stages, the sequential orchestrator route was what we went with internally, and which led to us building this Whisperer multi-agent system, right? But before we did, we looked in the market to see, what were some of the existing frameworks, right, that we could have taken off the shelf. Now, interestingly, this coincided with the time where the race to deploying frameworks for this particular problem was happening. I think just a few weeks before, OpenAI had released the Swarm Python multi-agent workflow. I actually do spend a lot of time writing Python. I joke around and say that I actually think in Python. And then, I think in Python and then I convert it whenever I'm writing other programming languages. So I'm self-proclaimed Pythonista, but, and this fits into the next thing I'm going to discuss, right? But I think it was for anyone who had a lot of experience with other programming languages, I think the first sense I had when I was going through Swarm's GitHub was it felt like you were forcing a paradigm to you were using a tin cutter to open a bottle, right? It felt like you were using the wrong tool for the wrong tool for the right problem. And I would speak a lot as to why I think Elixir is great for building multi-agent systems, right? But that being said, I think a lot of the developments we've had in the AI space in the last couple of years, not even the last couple of years, probably going back 10 years, as happened within the Python community, right? So when you go back to stuff like PyTorch, when you go back to stuff like Scikit, um, and now agents, right? So LangChain, LangChain set the direction in terms of like how you would see the interfaces and even some of the core logic of how a lot of multi-agent systems frameworks are built today. I think LangChain set the pace, and then when the bottlenecks with LangChain, mostly LangChain offers you like a sort of struct and entity and sort of, oh, this is how you should be thinking about different processes and agents interacting with each other. But LangChain does not really provide you with a way to define or sequence workflows. And they noticed when you begin to use LangChain in production, they noticed that problem, and which is what we also noticed. We're using an Elixir port of LangChain within our application, and then on the Python side, the LangGraph I think came out sometime in maybe Q2 2024, if I remember properly. And LangGraph is increasingly becoming the de facto approach for building out complicated or complex workflows for multi-agent systems within Python. So this existed in the market, and this LangChain, LangGraph, in my opinion, are sort of the de facto market leaders when it comes to this domain. And so, the idea was, okay, why improve on that, right? Why build something, right? Because you really need to know the why, right? I don't believe in writing code just for the fun of it, even though I like writing it for the fun of it. But there has to be a reason for why you're doing what you're doing, right? And for me, the biggest thing was the idea of agents, being isolated, agents, being as best as possible autonomous, right? And this was one thing I referred to when we're speaking. Now, the way Python is structured, the way a bunch of some of our favorite programming languages are structured are such that the language itself forces a sort of inherent sequentiation or single-threadedness, or like things have to run in order, right? So I know Python recently removed the lock, right, which means that we should be seeing a lot more multi-threaded Python applications. But previously, by design, Python runs things sequentially in a single thread. And so where you're supposed to have, let's say you were implementing a parallel workflow, or you were implementing a sequential orchestrator workflow, where you're supposed to have each agent being an isolated process or unit running on itself. By the very design of the programming language, what you see is a facade, right? Yes, the APIs might make you think that that's what's happening, but in truth, what you're doing is actually switching. You're trying to switch as much as possible, but those agents are not autonomous, right? And if you go through Swarm's implementation, you see that this is very clear, right? You'll see lots of, oh, for agents in agents, that kind of stuff. And fundamentally, we felt like, okay, we are already working in a language that has a lot of paradigms that can actually provide the idea of a fully autonomous agent. So why can't we build on that? And this was really the inspiration for building our Whisperer. some of us on the call might be familiar with the actor model. The actor model is a core model to functional programming languages, and especially Elixir. And what that means is that within the actor model, each process exists individually by itself and owns state and provides an interface, right, for being able to reach out to that state. Functionality is communicated via message passing, where you have like, think of it as a room, and there's a mailman going around giving messages to different processes. Processes have process IDs that you can use to identify them, and they can also use to identify others, right? And so if you made agents analogous to a process or an actor or a series of them, then by doing so, that agent would be truly autonomous from the perspective of the running system, the running program, right? Besides that, resiliency was also a concern. It's almost a given, right? That every time you're using like Cursor or Copilot, right? For every 10 activities you try to complete, maybe one goes down, right? In agent mode, right? And I think because we understand the complexity of the domain, that's already a given. That's already something that we are all okay with, right? But with Elixir, there's this concept of the gen servers and supervisors. And what that means is that a supervisor is essentially another process watching an executive process, that if the executive process goes down or fails, the original, the supervisor goes to start that up, right? And this is all achieved using the BEAM, the Beyond Erlang Abstract Machine. And the great thing about this is it's also amazing for scale. So if you've heard about Erlang or Elixir, parallelization and being able to handle multiple concurrent requests is one of the talking points about using this paradigm, because the actor model means that you can individually scale. So think about it in Python, where you have a single thread running a single set of processes. The Beam can have millions of those actor models, where each actor is maybe responding to your own API request. And so scalability is amazing with this, right? I see we're running, time is a bit not on our side. I'm going to skip this a bit because I think I've spoken as to why, things that you should have when you're building an agentic framework: scalability, reliability, reproducibility. An important one is, the APIs, right? It's a framework, so you want to make sure that you're building something that people can take off the shelf and easily implement. And to be honest, I think we did LangGraph and LangChain really helped us with that, right? So let's get into the core of it. I'm saying that this is not too large. My apologies for that. But if you look at this, right, you would see that we have four or five major areas, right? You can see the orchestrator, which is the rhombus in the middle, and then we have the sequencer. The sequencer is aware of all the agents that exist within the domain, and essentially sequences and creates how it believes that the interaction should happen, and the workflow should go from agent to agent, right? After the sequencer creates that plan of action, it provides it to the orchestrator, and the orchestrator then basically begins to delegate work to each agent, have those agents execute the work, get outputs, harmonizes it, and all of that. And at the end of the day, after executing the workflow, returns the final result to the invocation engine, right? Um, yeah. So I think the final thing I'm just going to talk about is the core of the orchestrator, or the core of the framework, which is the orchestrator, just so we can have 1 or 2 minutes to take questions. And this feeds back into a lot of what Ayo was saying, right? That at its core, learning a lot of the foundational knowledge like data structures and algorithms is really important, right? Because at the orchestrator, what the orchestrator does is the orchestrator essentially uses a graph, and as well as a graph traversal to be able to execute the agentic workflow. So the sequencer provides it with a graph representation of what needs to be done, and the orchestrator using either a BFS or a DFS traversal algorithm. I think today we use a BFS approach. Would then take that graph and execute delegating work to each agent, getting a response, and moving that across the graph all the way till its termination point. So it just goes to fit into the idea that, all the knowledge that we pick up, sysconf, doing our individual learnings, it all comes together when you're trying to, push the envelope of what you're trying to do, right? I'm going to stop here for today because I would really like to take questions. Ace.
Yes, thank you so much, Pelumi. Thank you for this exciting session. It's exciting as a Java lover. It's exciting to see. It's
Yeah.
exciting to see Elixir, a functional language that also has many of these frameworks behind it, and I mean, it's exciting. So we have a couple of questions here on the Q&A.
Okay.
The first one is from Opeyemi, and he says, the main drawback of AI agents is their tendency to hallucinate and go rogue as a result.
Yeah.
Are there any concepts in these frameworks that guard against this? I don't know if you can help. Yeah.
Yeah. So I'll give you two answers. I'll give you what, if I'm selling Whisperer to you, what it is, and then I'll give you the no bullshit answer, right? If I'm selling Whisperer to you, I'll tell you that the fact that we're using the actor model, which means each agent has its own isolated state, right? So for example, if and this is what happens with Whisperer today. Let's say you were trying to work on a booking, and then we had one that was responsible for checking out, one was responsible for checking out booking.com. An agent was responsible for speaking to booking.com, getting all the responses for booking.com. When you issue another query, gets another set of responses and keeps it in its own encapsulated state, right? So this is not global shared state, which is what typically happens with a lot of the popular frameworks today, right? In doing so, because it has its own isolated states and that is what it cares about, your tendencies of having your business or your customers perceive any sort of hallucinations is very minimal because we're not going to lose that state, right? That's the whisperer sales solution, right? But in truth, I would say that memory and state is not yet 100% figured out within this paradigm. And why I'll say that is because, for example, with what I've described with the actor model, I did mention that this processes can go down, right? Something can happen, maybe in trying to communicate, make an external call, make a tool call, whatever, they can crash. And then if it crashes, right, for all intents and purposes, except we have used a persistent storage solution to also store that state per process, which if you look at it is not very practical, you are going to lose that state, right? So the honest truth is the tendencies for hallucination from an end user perspective are minimized, but they are not down to zero. And I want to see a world in which hallucination is down to zero within this world, this new agentic LLM based world. But I don't think we're there yet. I think we're making incremental progress towards that. But the honest truth is, I don't think there's a tool today that would exist that would 100% never hallucinate or lose information or forget that you told them something. I just don't think we're there yet.
Okay, thank you for that. A lot more questions are coming in, and for those I can't read, I'll suggest that you just network with Pelumi. I'm sure he's going to be around. You just network with Pelumi and then ask him. And the question I'm going to read now from Habib, and he says, "Is a sequencer orchestrator workflow simply the classifier workflow across multiple steps?"
Yes, I would say that you can think about it like that, because across multiple steps means that you can change stuff, you can have more complex stuff. I think another way to also really think about it is the fact that you're having a separate box that handles the idea of what should be run. So in doing that, we say specialization is great, right? So if you have a different box backed by an LLM that is specialized in the idea of what should be run and when it should be run, and you have another process, right, that specializes in executing what should be run and when it should be run, By doing that, you improve the resiliency of your system, you improve the accuracy of your system, right? So that is one way to think about it, and that's correct. But I think what I've described is a lot more encompassing.
Okay. Thank you very much, Pelumi. Thank you so much. This has been an exciting session. Thank